Hi, my name is Milin Kiran, and I will be briefly presenting my final year project titled Detecting Polarity and Concepts in Climate Change Tweets Using SenticNets. Climate change is the hottest buzzword that we're all hearing on a daily basis, and everyone seems to have an opinion on it. Experts are providing facts and figures that we need to achieve net zero in the next decade for the planet to survive, while there are digressors who think it's all a hoax for governments to deflect from present and ongoing issues. To mine these opinions that everyone has and to quantify them into actionable insights, sentiment analysis is used. What is sentiment analysis? It's a natural language processing task that classifies textual data according to polarity, like positive, negative, and neutral. Some models of sentiment analysis even break down the degree of positivity, negativity, and neutrality in the text. Sentiment analysis is extremely important as more and more data becomes available online with the opinions of people from all over the world. In order to make effective policies, address public concern, and broadcast the right messages, it's important for governments, multinational corporations, and citizens alike to know what exactly is going on in the minds of other people regarding global issues like climate change. Where better to find textual data than social media? And the one that has the most opinions, Twitter. With 217 million daily active users, there is no dearth of public data. Twitter users can post tweets which are short, textual messages, usually of 140 characters. Twitter is also extremely fast moving with real time data available about trending topics. We can mine facts, opinions, jokes, rants, so we really have a wide variety of data to analyze. Here are just some snippets of climate change tweets from November 2021. What does this project aim to do? Before I identify the goals, I would like to explain what SenticNet is. SenticNet in this project context is an artificial intelligence and semantic web-based method of opinion mining and sentiment analysis. It was developed by the SenticNet team, which is headed by my supervisor, Dr. Eric Cambria, with whom I was fortunate to work with. So the goals of this project are three-pronged. Using SenticNet to classify polarity of climate change tweets, using SenticNet to extract important concepts in climate change tweets, and identifying issues and misclassifications and suggesting recommendations. So for the data collections, two different data sets were collected over different time periods. They were mainly queried using the Twitter Developer API using keywords like climate change and global warming. The two datasets differed slightly in the hashtags that were prominent, depending on the time of data collection and trending topics. The data was annotated in two ways. The first dataset was annotated using an open source sentiment analysis tool called VADER, which classifies texts according to a compound polarity score. The second dataset was manually annotated. Here are some statistics of the tweets classified by the VADER model. And here are the tweets that are classified manually. So upon querying these datasets through SenticNet, we get the following results. For dataset 1, 61.2% of the tweets were classified as positive, 38.6% as negative, and only 0.2% as neutral. This is because SenticNet is an advanced knowledge base and even subtleties in text are detected easily by SenticNet. I also queried the tweets on SenticNet's concept parsing tool, which gave me a list of concepts among the tweets, and these were the most common concepts. I don't really check for accuracy of SenticNet's performance for dataset 1, as the target labels have been classified by another sentiment analysis model, but a comparison has been done upon analysis of the tweet classification by both VADER and SenticNet. It has been found that on comparison, SenticNet detects even slight negativity or subtle negativity in text. SenticNet detects sarcasm in text when it is obvious while VADER does not. SenticNet considers the context of the sentence while assigning polarity, whereas VADER averages the polarity score of the sentences and gives a compound polarity which may or may not be correct. We move on to dataset 2, which was manually annotated and found that 64.2% of the tweets were classified as positive, 35% as negative, and 0.82% as neutral by SenticNet. Common concepts in the dataset included change, new, water, impact, which is mostly similar to the concepts identified in dataset 1. I found that when testing for accuracy, SenticNet correctly classified 56.38% of the tweets exactly as the manually annotated ones. The score may seem low, as when manually annotating, many were identified as neutral due to the ambiguous nature of the tweets. SenticNet delves deeper to identify slight positivity and negativity and classify them as such. Hence, there seems to be a disparity in the numbers. Nevertheless, it still is one of the best performing sentiment analysis models available. Here, I identified some issues due to which SenticNet may have misclassified tweets. First, word ambiguity. The problem of word ambiguity is the impossibility to define polarity in advance because the polarity for some words is strongly dependent on the sentence context. Sarcasm and irony, when bad feelings or negativity is communicated using good or positive words. Multipolarity, in many circumstances, relying solely on the study's overall outcome can be deceiving, similar to how an average might conceal important information about all the numbers that went into it. So a piece of text might have multiple polarities which may be equally important. Negation. Negation can be expressed in different ways, morphologically, implicitly, or explicitly. The quality of a data set for training and testing sentiment classification models within negation will improve if samples with different types of reported negations are included. So what is the way forward? After identifying the most significant issue and the most feasible solutions, the future work of this project will include developing a model that solves aspect-based sentiment analysis, which is a more general and complicated task than regular sentiment analysis, where we predict the aspects mentioned in a sentence and the sentiments associated with each one of them. Using a deep neural network that combines aspect prediction with sentiment prediction will be the scope of the next steps. With that, I conclude my presentation. Thank you very much.